Hello, welcome back to Math with Patrick. Today is June 6th, and we have problem number 157 from the Daily Epsilon calendar to solve for today. And apparently the answer is 6, and so we need to figure out why x right here is equal to 6 today. So I see two things. The first thing I see is some kind of equation for the variable y. It looks like some kind of infinite sum. And then finally, once we figure out what y is, we're going to plug it in here, do some arithmetic, and then get the number 6, apparently. Looks like the bulk of this problem is hiding in this sum right here. So I think for starters, I just want to unravel what's happening here so that I get some kind of equation y equals something. And that's ultimately how I'm going to confirm whether or not I'm right for today. So if we have x is equal to 2 times pi over y squared, I'm just going to do opposite operations. So I can divide the 2 to the other side. So I'll get x over 2 is equal to pi over y squared. I'm going to hit both sides with a square root. So then I'll get root x over 2 equals pi over y. It is good to note that there probably should be a plus or minus sign here. But I'm noticing that this value is always positive. I think maybe it's probably always positive. I'm seeing 8 divided by probably a positive number. I think when we plug in some numbers here, because we're adding a lot of stuff, and n is always 0 or positive. Essentially, I think the fraction is going to be positive. So if y is something positive, then pi over y should also be something positive. So I'm just going to ignore the plus and minus signs and assume that y is going to be my positive solution. And then whenever you have this kind of setup where one expression equals a fraction, you can always swap the denominator for the other expression. And so I'm going to get something that looks like this. And x is 6 today. And so that would be y equals pi over root 3. And how about let's just kind of keep it at that. I could rationalize the denominator. Maybe that'll be necessary for my last step. But for now, that is my supposed value for y today. So now we need to target this sum and figure out why the heck does this sum equal pi divided by the square root of 3. That's really bizarre to me. Just for starters, I kind of want to walk through what it looks like finding the sum. The first thing you do is plug in this lower bound into any spot you see this letter n. And so we would get 8 over 0 plus 5, which is just 8/5. And then you would add the next term once you plug in a 1 in all the spots where you see an n. And you're just going to do this process up until you hit the top number. But the top number here is infinity. So this is an infinite sum. We're going to have infinite terms. There's no way for us to just add them all up one by one because it would last forever. I do just want to get a little sense of what's going on with this sum. And so I'm going to do the next term and probably stop there. Plugging in a 1, I'll get 36 plus 36, then plus that 5 at the end. And so the, first term, right, when n equals 1, that's the first term. And when n equals 0, that's the 0th term. Or maybe you can just call it the second term. I don't really care. But the next term in the sequence will be 8 over, and then this makes a 72. So it will be 77. So we're just going to keep following this pattern, and it's going to be 8 over some wacky denominator. At least maybe that's one thing we could do. We could factor out the 8 out of all of these terms, right? Because the next one's also just going to have an 8 in the numerator. And so we could go 8 times the sum from n equals 0 to infinity, and then this kind of sum here. So with that being said, we have a good-ish idea of how the sum is working out. It's growing. We are getting a positive sum like I was kind of hoping from before. But how do we assess this part? So I'm honestly really not sure if this is going to work, but I'm just trying things out. I noticed that the denominator here is factorable, and there's something we can do about that. So first off, I want to just kind of show that the denominator is indeed factorable, and it's going to be 6n plus 1 times 6n plus 5, right? Because if we FOIL it out or distribute all the things, the first two terms create 36n squared, the outside terms create 30n, the inside terms make a 6n, and then finally 1 and 5 make, well, 5. And then adding up these middle terms shows that these two expressions are the same. So I could factor the denominator, and I'm just going to kind of investigate this part right here first. And I'll keep the 8 in there, I think. 8 over 6n plus 1, and then times 6n plus 5. And anytime you have a fraction whose denominator is factorable, you can write it in partial fractions. The idea is like, say we had like 7 over 15. I know that we can create this fraction with some amount of fifths and then some amount of thirds. And then it's like a little bit of a puzzle to figure out how many of each you need, but it's definitely possible. And so I'm going to do the same thing here, where this fraction is going to be equal to some amount of 6n plus oneths and some amount of the other denominator. And I just need to figure out how many of each I need. And one way to do it is just, well, first off, set this expression equal to that, because when I'm decomposing this fraction, they should be the same. And then here, if we multiply both sides of the equation by the denominator on the right, we're going to get some nice cancellations and get rid of fractions. There will just be an 8 on the right side. This factor will cancel with that one, and so we'll be left with a 6n plus 1 on the top. And then similar cancellations over here, we're going to be left with a 6n plus 5 over here. And then what do we do here? Maybe let's distribute some stuff and see what happens. We're going to get a times 6 times n plus b times 6 times n. I'm doing these distributions first. Then we're going to get a 5a plus a b, and all of these altogether are going to be equal to 8. And the interesting thing here is that there's no n's on that side. And so I know that these two terms that have the n need to cancel out. This shows me that a is equal to negative b, right? Because maybe this is a 2. If that's a 2, this has to be a negative 2. If this is a negative 3, that has to be a positive 3 for the n's to cancel out. And once these cancel out, then I'm left with 5a plus b equals 8. And so I can write a system of equations here. I'm going to actually rewrite this one as a plus b equals 0. That kind of expresses the same idea. And then I have 5a plus b is equal to 8. And then let's do some elimination. Oh, wait, sorry, that's 8. I'm going to subtract the top equation from the bottom one. So I'm going to get 4a equals 8, right? The b's cancel out. 5a minus a is 4a. And then so that tells me that a is 2, and then b is negative 2. All right, that's cool. I just kind of threw some numbers out there, but it seems like the 2 and the negative 2 were the numbers that work. So now that tells me I have a partial fraction decomposition of my original fraction. So I played around with the partial fractions that we found. Here's that 2, because a was equal to 2. Here's that negative 2 for b. And these two things are equal to each other. And the thing on the left is just the sum that we're working with. So if I plug in n equals 0, 1, 2, 3, all the way to infinity on the right side, it will be the same as the left. And so these two fractions are when I plug in n equals 0. These two fractions here are when I plug in n equals 1, and so on and so forth. And so this whole sum with the 2 factored out on the left there is equal to y. Now, I was investigating this sum, and I found some good sources online that demonstrate what this sum is equal to, but it's really not something that I feel like I can talk about in a really concise amount of time. So It's like a trust me on this kind of moment, but I'll put the links in the description below so you can investigate it yourself if you want to. Here's where you got to trust me. This alternating sum is equal to pi divided by 2 root 3. And it's not obvious that that's the case. There's many complicated calculus plus topics that you need to look at, but that sum is equal to pi over 2 root 3. So if we pull that value right here and let those 2's cancel out, then we are left with y is equal to pi over root 3, which is precisely the value that I wanted to show earlier. And so this is a sufficient condition to say that yes, x is 6 today, and we're all done. So do check out those other sources in the description because it helps explain how I'm getting this value from that alternating sum. But if I talked about it here, this video would last half an hour or more, and I don't really want to do that. Also because the other mathematicians already put in all the work, and I want to credit the people that I'm pulling my math knowledge from. So anyways, the answer is 6 today. That's all the math I got for you, and I'll see you tomorrow. All right.